Ladies and gentlemen, welcome to the premiere of the first Delft Hyperloop documentary. It's good to see that in these unusual times, so many people come together to experience this special evening. But we're not alone. There are also people watching from home via our livestream. Nice to have you all here. My name is Romee Posma, and last year I was part of the Delft Hyperloop team. At that time, I was responsible for the public relations, but for now, I will guide you through this evening. But before I do that, I would like to invite our team captain, Emma van der Ven, on stage to address to you for the very, very last time this year. Emma van der Ven.
Thank you very much, Romee. Good evening, everyone. My name is Emma, and it's been a while since we last came together, also with the team. And although our record attempt was about 2 months ago, to be honest, I can remember it as if it was yesterday, but it feels like ages ago. Life is quite different now for most of our team members. We started studying again, or doing an internship, or taking a well-needed break. So it's really nice to have you all here tonight. And I think because life is so different now, that now is the ideal time to look back and appreciate what we've been through. I also remember about half a year ago that we sat together to think about how we wanted to capture the end of our year. And we had a long and good brainstorm, and the main thing that came out of it was that we wanted to tell our story. We wanted to show you the highs and the lows of such a record attempt and everything that led up to that record attempt. And to show you that this year is about so much more than that one day. And here we are at our documentary, the premiere even. And if there's anything, I hope that you enjoy our story. Have a nice evening, ladies and gentlemen. Thank you.
Thank you, Emma, for your lovely words. Now it's time to see what's on tonight's schedule. So first we're going to watch the documentary, Breaking Barriers, which takes about 50 minutes. After that, there's a presentation of one of our strategists about the future of Delft Hyperloop. And finally, we have a Q&A where you can ask all the questions you want to ask about the team, the pod, or the future of transportation. So, the moment we all have been waiting for is almost there. The short documentary of Delft Hyperloop, Breaking Barriers. But why did we make a documentary? Well, for everyone, this year has turned out quite differently than expected. Also for us as a team. We couldn't go to SpaceX anymore, but we still wanted to show the world where our pod was capable of. It was no time for regrets. There was no way back. It was all or nothing. Is the audience already a little excited? Are you sure? Well, then it's time to present to you the short documentary of Delft Hyperloop, Breaking Barriers.
Ensure the track is clear of any mess or people.
When you see that it will all be boiling down to this very one moment, it's quite nerve-wracking.
Accelerating in 5, 4, 3, 2, 1, go.
Well, the general concept of a Hyperloop in a nutshell is that it is a revolutionary mode of transport where we travel inside pods which are levitated in the air through magnetic levitation, and these pods travel through low pressure tubes.
And because of the lack of air and rolling resistance, Hyperloop vehicles, or pods as we like to call them, are able to travel at speeds of 1,000 kilometers an hour.
There are more
more about hybrid, more about your trip. You have all the feelings of the outside with the Skype.
The goal of previous years was to be able to participate in the SpaceX Hyperloop pod competition, and due to circumstances that hasn't happened this year. So now we have set our new goal to be in open air on our own test track in Hilversum, where we try to reach a new speed record.
Where shall we put this boy?
We're building a prototype of, you could call it the locomotive of a Hyperloop. So a prototype of a vehicle that propels along this track. We're going to use an external track which is just under 400 meters. And within this 400 meters try and reach the highest speed possible and almost certainly break the record from our previous teams, which was 202 kilometers an hour. It's all about really using every little bit of the track and tuning the system in such a way that we brake at the perfect position to not go off the end of the track, stay safe, but to reach the highest speed in the shortest amount of time and distance.
Nick, jij zegt dat we die bolts moeten aantorken in die battery box. Van tevoren, oké, dan zet ik dat in die installation procedure. What my role in that is to make sure that the best of each department and the best of each subsystem performs as one beautiful machine.
You start with 33 new people that don't know each other. You have nothing that is already made, and you start at the drawing table. And then you design it, you build it, you assemble it, you test it, and at the end of 1 year you have this vehicle that can perform at speeds that are really high, and that is quite impressive.
To explain full functioning and working of the pod, I started at its core, which is formed by the chassis, on which every other system is bolted. The braking system is bolted in the middle. Afterwards we have the mechanical suspension, which makes sure that the vehicle is straight and level. When those three systems are together, our mechanical part is done.
We want to make about 4 to 5 wheels out of this piece. So we're making grooves that we know where to cut the wheels, and then afterwards we'll finalize them with the right fitting and so. On one hand we want to disconnect ourselves completely from the track, but on the other hand we clamp ourselves to the track so that we can have the most traction and therefore the most forward force. And when the suspension does not instantly react to an irregularity, they would be hit by the track. But for braking, it would be best to nearly touch the track. Overcoming a 1 millimeter obstacle should not be as difficult as it is. But it's just the uncertainties that you don't know that will form the risk of failure.
So we have all these different departments that focus on specific aspects of the run. Propulsion is purely focused on the motors and how to get them running as quickly as possible. But these motors don't do anything without power, without energy. For this we have 2 extremely densely packed battery boxes. Both of these systems, the motor controllers and the battery system, they don't work by themselves. These commands originate from our software and our hardware, which could be seen as like the glue of the vehicle. The main component is this microcontroller, which runs all the software, and via all these connectors is connected to the different subsystems, and it reads out sensor data, values of all the other subsystems, so speed of the wheels, pressure in the braking tanks, battery voltages to see if the health of the battery is good. By reading out these sensors via the PCB, which from then the PCB spreads out over the whole vehicle with wires to connect and control every subsystem.
So today we're at Hilversum at our long test track, and the idea is that we push our vehicle even further, because at our base in Delft we've already tested until about 20 meters, and here we have almost 400 meters. So we increase the distance and we increase the speed so that eventually we're ready for that record attempt.
Yeah, we really want to get all the testing done to see the performance differences of our vehicle and see at what points we can really get the edge for the wrecked attempt next week.
Zo, bliksemschicht is alles wat aan is, toch?
Bliksemschicht is de uitgang.
Krijg je doen? Ja, ik krijg hem erin, maar gaat niet helemaal door.
Heb je er al langer?
Ja, ik heb wel langer.
3, 2, 1. Today's quite a warm day, so the sun warms up both the vehicle and the track. Actually for the track it's quite beneficial because now the beams that hold the track together are more tight. For our vehicle itself it could be potentially challenging for both the batteries and some structural elements.
I guess everything can kind of go wrong on a day like this. But yeah, the main new feature for today is the aeroshell, which we've tested indoors but never on high velocities.
Bijna. Iets terug en achter.
Ze zitten vrij hoog, dus je komt er met je handen er niet bij.
Dan kunnen de MID switches aan.
People are definitely nervous on a day like this because here it goes, what is it, 200, 300 kilometers an hour, and it's really fast, and it's just really cool to see but also really scary because people have designed it themselves and sometimes they're afraid if everything will hold.
We've programmed our own control software on the pod and it automates the entire run, but once we press enter the whole run is autonomous. So before a run we'll check all the settings and all the data, double check it with multiple people, see if all the systems are all in good health and all ready, and as soon as we know everything's ready we enter a ready for accelerating state which turns on all the high voltage systems to power the motor controllers, and that's when we initiate the run and transition to accelerating state.
Sta jij alweer in positie? Ja. Ensure the track is clear of any mess or people. Accelerating in 5, 4, 3, 2, 1, go.
We almost reached our speed of 400 kilometers an hour, but I long for more because I feel that there's more potential in the vehicle.
The magic barrier of 400, and I think we can still go faster, but we just need to analyze everything and see where we can win some speed for next run.
This moment we are looking at the bolt connections, that they are at a proper force, that they can support everything and that the suspension is stable because of that. Als je hem andersom doet en een nut eruit valt, dan houdt de zwaartekracht de bout vast. At the point that we forget that it could go wrong at any place, then it actually will go wrong.
Hier moet ook nog een nut op. Deze nog even net op. Daar ook niet. Allebei niet? Nee.
Oh, oké, nee. Dus de tubings zijn vast. Aan de andere kant plexel tubings zijn vast. Volgens mij zijn we nou klaar.
My year will be a success when we're standing there at this record attempt and everybody has this feeling of like, we did it, guys.
How amazing would it be if in 30 years you would travel in the Hyperloop and think that is something I've worked on? That would be truly remarkable.
The current Delft Hyperloop record is set at 202 kilometers an hour and it was set by the previous team in the SpaceX tube in LA. Our goal, break that record. We'd like to go above and beyond. And we have 386 meters to do so, with an acceleration of 2g and a deceleration of 20g. And I'm really happy that you're all here to witness it, because this is what we worked for this year, and I couldn't be prouder. Let's break that record. Thank you very much.
Kijk, we hebben die 400, dat is een grote bij. barrière. En de volgende echte barrière is als we een beetje in de buurt van Tim komen. Ik ben confident dat als we vorige keer er zo dichtbij zaten, dat we er sowieso overheen gaan. Because of all the tests we've done throughout the year, everybody's gaining more and more faith in our system. Instead of just designing it, we've also proved it multiple times. The only real difference today is we're really pushing everything to the limit and getting everything optimal instead of testing like different aspects of the system. But everything's been tested and we haven't had any weird issues, so I'm positive.
After having worked on this for a whole year, putting all our energy, dreams, sweat into it, when you recognize, when you see that it will all be boiling down to this very one moment, it is quite nerve-wracking.
Heel veel succes! Hyperloop 4! Yo!
Het gaat natuurlijk al van die batterijen temperatuur.
Ik ben in positie, Robert en ik.
Zeg je dat het nog oké is?
In positie.
Ik ben bang dat de ladies hem
If the track is clear of any mess or people, we are going to accelerate in 5, 4, 3, 2, 1.
Nee, dat is niet goed hoor. Dat is niet mooi. Remstof of niet? De remstof op rood.
Dat is goed. IMD en contact aan mijn kant goed. We zagen wel vuur.
We saw some sparks, kind of didn't want to expect the worst. Nothing really bad happened. Once we looked at the data, we knew pretty quickly. We saw one of the motor controllers lost connection and that triggered the emergency brake. So kind of put one and one together. So it's kind of bittersweet. I'm glad we beat it and beat it well. But personally, like the 400 would have definitely made my day even more.
Which is really a bummer, but there's nothing to do about it. That's the thing, if you have one chance, then it's all or nothing. And we reached 360, which is really nice. We hoped for more, but we're still very happy.
It's just a crazy experience. This whole year working 40 to sometimes 80 hours a week, spending all the time with all the colleagues you have, all really working and pushing the technology further. It has been an amazing year, but also a lot of fun.
But at the end of the day, we have set an amazing achievement about which all of us, every single team member can be proud, including myself.
And I think especially the long shifts with everybody when you spend hours and hours trying to fix a problem and then finally fix it in the middle of the night or early morning, those are the kind of moments I think we'll remember the most.
Today was nice, but the whole year was nice, and it's the overall experience. And today is just a part of that. And I think if I look back, I'll remember how challenging it was sometimes, but also how much I enjoyed it.
Wow, what a documentary. Of course, we couldn't do this on our own. We partnered up with two professional filmmakers and 3D animators. So let's put our hands together for Jan Willem Nijsink and Maarten Kal. Please come here. So thank you very much for all the time and effort you put into the documentary. I think the result is very impressive. Nice. So maybe let's start with you, Maarten. Where did it all start for you?
Yeah, I even prepared a little speech. I'm not so good as the way I was talking by heart, so I wrote it on my phone. And like this, everybody can hear me, hopefully. Yeah, for me, the story started a year ago, like for everybody, I guess. And it was Jamil sending me an email with a question, like how would I make a documentary about the Hyperloop project? And I looked into it, and I thought it was super cool. And I invited the team to my studio. And we had a long talk about the Hyperloop project and how we would go to LA and meet Elon Musk and win the competition and make a great documentary about it. And yeah, I was thrilled. And so the weeks after, it kept spinning in my head, the Hyperloop. But yeah, it was a few months when I heard nothing, and then we heard some bad news about that Elon Musk and LA was not coming through. And then a few months later, Corona came, and to be honest, I thought it was not going to happen, or at least not the documentary part of it. But then, I think that was in June, or maybe the end of May. And then suddenly I got a call again, and like, hey, we have to meet, and now we finally know what we're going to do. We're going to break our own speed record in Hilversum, and we want to have a film about it, and we prepared everything, and can we come by, and we want to shoot next week. So we had another meeting, and like from there things moved like super quick, and from there we prepared the script, and we planned the first shooting day, and 1 week later we were filming. So that was great. I wrote some things down as well before I start freewheeling. So like as a documentary filmmaker, I try to find the part of the story that interests me most. And for the Hyperloop documentary, it was really, what really I found the most interesting and the most cool about the entire project is how like this team of like super young engineers and brilliant students like kind of come up with this project, design everything, build everything, organize everything, and it's sort of wow, this is, I don't have a technical background, and for me this is like amazing, you know, how does it work? How do they do it? So I thought to really celebrate that technical knowledge, I really wanted to know like how they do it. I think one of the things that we try to do with this story and with this documentary is to give a little bit of insight into the technical workings of the Hyperloop pod. So I hope that now everybody knows like how they can make like a small pod in their back garden. Maybe watch the film another time, but and also thanks to Jan Willem for like the amazing, stunning 3D animations that really help to clarify this process and to visualize the technical working of the pod. And at the same time, I think the film is apart from all the technical functionality of the pod and all the different aspects and teams that work on it, it's also like a film about a team that's trying to achieve something, and that's working together and collaborating and trying to break their own speed record. And I found it amazing to following that story and to make a film about it. Well, in the end, we shot the film in 4 days. Well, we've all seen the end result, and I hope you enjoyed it as much as I did making it. Well, thanks very much.
Thank you, Jan. Thank you, Maarten. Okay, then one more question for Jan Willem. What did you find most interesting about working on this project?
I think in global, as you are a technician of your technical background, if you hear the line Hyperloop, then I think a technician's heart will beat a bit faster. But it's a cool project, it has speed, it is all what a technician is interested in, I think. So that's only the question from will you create the technical animation shot for it was a nice question. So yes, sure, we did it. But also working with the team was nice. We have a technical explanation at the base in, I think in Delft. It was Sasha explained all the technical details about the pod that help us creating the 3D animation. So we understand all technical details and we can match it with the film and all the details that where they are talk about in the movie. And I think my personal main goal was the PCB, because we are normally animate big machines or production lines or chemical plants, that kind of stuff. That's large, but it was very nice to put all that effort in such a small thing and make it highly realistic. When I received all the details from Sebas about the PCB, the layout, we can create that very realistic rendering. Personal, that was a nice thing to make. Dus thank you to all the team to participate in this project.
Thank you. So we have a small gift for you. Thank you. Wil je hier blijven staan? Thank you. Give them an applause. So, now we've all seen a documentary, you all know how this year ended for Delft Hyperloop. But is this really the end? Well, luckily not. A few months ago, we recruited strategists to think about the future of Delft Hyperloop. And tonight is the night that they, for the first time, will present their future vision to the outside world. Give a warm applause to our strategist, Joost Smeets.
Okay, so now we start to talk about the future of the team. Thank you, Romee, for your kind introduction. And guys, it was indeed an amazing documentary. Good evening. It's great to see so many of our Delft Hyperloop team members, as well as Delft Hyperloop alumni, as well as dear friends and family here tonight. And also a special welcome to all the people that are watching right now via the live stream. It is great to come together in such a way during these difficult COVID times. As Romee said, I am Joost Smeets. And I want to thank you all for coming here tonight and joining me to reveal the future plans of Delft Hyperloop. So let's get into it. First, I will start with the small introduction of our very ambitious strategy department. This will be followed by the situation that needed the cause for our existence. Then I will talk a little bit about the approach we took and conclude with our newly formed strategy for the team. So this is us. 3 dedicated TU Delft students with all different backgrounds. On the left-hand side you see Marijn Rogge, who has a background in mechanical engineering. In the middle you see Mano Viraj Singh Sherjil, who has a background in complex systems engineering. And on the right, you see myself, Joost Smeets. I have a background in systems engineering, policy analysis, and management. And this department is actually unique in the future of Delft Hyperloop, since it had never been before, had been formed before. But why was it necessary to have such a new department? That is because of this. Imagine that you're hired to the Delft Hyperloop team. You give up your studies for an entire year to work towards your goal, which is to go to LA at the end of the year. There you will meet Elon Musk and are able to compete against other Hyperloop teams, student Hyperloop teams, from all across the world. But for last year's team, this goal never came. I'm sorry guys of Delft Hyperloop 04, you heard it many times, but it's a story that has to be told at this stage. However, I can say that you did an amazing job in breaking the speed record with a stunning 360 kilometers an hour, which really showed that you handled this setback with great professionality and resilience. But this was not all that happened during this awful year. We also received the news from the Dream Hall that all Dream Teams will lose their Dream Team status for the next year. And what does this mean for Delft Hyperloop? It means that our access to the Dream Hall will be excluded for the next year, the year 2020-2021. Technical courses and essential usage of essential engineering machines were not at our disposal anymore, like they have been in the previous years. And then when you thought you've had it all, this one happened. A global pandemic shook up the entire world, of course, including Delft Hyperloop. And as you can all understand, hopefully, this is a situation that we never found our team in before. There were a very high level of uncertainty. And uncertainty is something that is very difficult for human beings to conquer. When economic markets deal with uncertainty, people will hold on to their money and stocks. When nations deal with uncertainty, movements of nationalism and populism grow. And this is because people want to hold on to what they're used of and to what they know. And they don't want to act according to the future, because the future is something that they don't know. And we asked ourselves, do we want to be like those people? Nah, we don't want to be like those people. We said to ourselves, never waste a good crisis. And that's why we came up with a general plan to achieve one or more long-term or overall goals under these conditions of uncertainty. So that's what we did. First, we looked at why we exist as Delft Hyperloop. From this why sentence, we decided on what our new long-term goal for the coming years would be. We subdivided this long-term goal into 3 shorter-term goals, which eventually lead to our new 3-year strategy. So we start with the why. And we start with the why because we as strategists, they think that every person knows what they do when they are doing it. Whether it is waking up out of bed early in the morning, brushing your teeth, having breakfast, or going to work, to sit in an office the whole day while the sun is shining outside. These are the things we do that make us human and distinct one from the other. But why do we actually do these kind of things? We think because every person has a deeper meaning to itself and an inner strategy that they want to pursue in their life. So this is something that we also wanted to do for Delft Hyperloop, to make sure that all actions taken in the future would be aligned with our why. So we analyzed the history of the team and we came up with this. We want to inspire future engineers to push their limits so that as a team we contribute to Hyperloop being the future of transportation. Yes, let it sink in for a while. Because we think that this is the essence of the team. Following from this, we thought about a new long-term goal. And from our why, we obtained that a lot of our Delft Hyperloop team members wanted to contribute to the Hyperloop being the future of transportation. But have we been doing that in the past? By reaching max speeds, by using electronic motors on a rail? We didn't think so, because this is what we see as the future of Hyperloop. A high-speed train that uses magnetic levitation and linear induction motors in a near vacuum environment to reach speeds that go above 1,000 kilometers an hour. So we said to ourselves, let's start engineering towards this. So that's why next year, in 2021, we will research and develop linear motors. The second year, 2022, we will research and develop magnetic levitation. And in the third and final year of our proposed strategy, we will use these new subsystems, combine them with the ones we already know, and develop our own scalable Hyperloop pod. These are our new short-term goals for the coming years. And because we have identified these goals, we are confident that we can hire a new team of engineers each year, future engineers each year, and can motivate them to push their limits while simultaneously working towards the future of Hyperloop. But how do we do that each year? In the past, our main focus was engineering. But since we're engineering completely new things that we don't know anything yet about, we will add research departments to the team. These departments will conduct the research that is needed into linear motors and magnetic levitation. After that, we will continue to engineer on our scalable pod, and at the end of the year, we still want to compete in a competition, because let's be honest, that's just too much fun to exclude. But we're not also only participate in a competition, we will also join other teams to initiate in one. And this is a process that will be repeated each year so that we can be sure that we will succeed in our goals. And this is the future of Delft Hyperloop for the coming years. At last, I want to thank Delft Hyperloop 04, the team of previous year, for all their help during the defining of this strategy. I could really say that we couldn't have done it without them. So thank you guys very much. And this is why I feel confident enough to stand here right now to say that next year we will be back in full strength with a team like this, with all people happy and smiling, to succeed our new mission in the coming years. Thank you very much.
Thank you, Joost, for your presentation. It looks very promising. So now it's time to turn the tables. You have heard and seen enough of us by now. So it's time to ask some questions in the live Q&A with our team members. So if you have a question about the team, the pod, the future of transportation, or something else, you can go to this website and you can enter the code 9540606. And then Zola will select the most interesting questions and we're going to ask it to our team members. So, what did you guys think of the documentary? Was it nice? Yeah? Ooh, that's good. So, we have a few team members here. Can you please introduce yourself, Kat?
Hello everyone, my name is Katerina Ines-Janisch. I was a structures engineer last year and have a background in aerospace engineering.
I think I already did my introduction, so. on to Timo.
You can always do it twice, right?
Yeah, that's true.
I'm Timo. I'm a computer scientist and software engineer. And last year I was responsible for the sensor control part of the sensor control system, the software.
Thank you, Timo. My name is Sam. I was in the suspension department last year. I have a background in mechanical engineering. Yeah, and I hope to be able to answer your questions.
Nice. Give them a warm applause. Okay, let's see. Okay, this is a nice question. Sam, could you explain what was niet zo mooi at the open air track in Hilversum during the documentary?
So, yeah, so in the documentary you hear a voice saying, dat is niet mooi, dat gaat niet goed. And that's me in the heat of the moment seeing some sparks. And I read the script of how the day should go, and it was like, go very fast, reach 400 kilometers an hour, go back to Delft, party. But I never read anything about sparks. So I was like, no, this is not according to the plan. So my first reaction was, no, dat is niet goed. It turned out to be not according to plan, but luckily everything worked out and the emergency brake activated. And we still reached an amazing speed, I think. So in the end it was good, but that was kind of my first scared reaction. Yeah, it was a fun experience though.
Yeah, so maybe it's funny to tell that like everyone was sort of had mixed feelings because we didn't reach, like we went slower than we went before, and things went wrong. But I was sort of happy because because things went wrong, and I anticipated that what could go wrong, and actually did engage the emergency brakes, and that it didn't go off the track. That would be even more disastrous. I think then we would have seen a bit more unhappy faces. then you would for sure know that this was not according to plan, right?
Okay, thank you, Sam and Timo. Next question is for Kat. Who set the record of 202 kilometers an hour, and how did you do so much better right now?
Ooh, that's a tricky question. I do believe that the 202 kilometers an hour was set by our team, but the year before. And how did we differentiate ourselves actually from the team before us? So our main focus this year was on reliability instead of going full performance and cutting off weight as much as possible. And I do believe that with this gain in reliability we achieved with our design, we were able not only to reach higher speeds, but we were so sure in our design, just as Timo mentioned earlier, that in the end, something went wrong, but we knew how to react to if something would go wrong. And I do believe that this is also one of the little successes, as you mentioned, that we can also celebrate.
And I think it's also good to mention that the year prior to us, so DHO3, really helped us a lot throughout our year. So they always gave their input, and they allowed us to really build on some kind of basis they had already been building. So it was a really nice cooperation. I think it's very nice to see that Delft Hyperloop is more than just 1 year, but it's also a continuous process of knowledge on top of knowledge on top of knowledge, and not just starting from the very start. So I think there's also a thanks to DHO3 for, and also DHO2 and DHO1 for their nice basis and nice transmission of knowledge to us. And I think that's also contributing to our great result in Hilversum.
A follow-up question for you, Kat. What are the aerodynamic challenges in reducing drag in a near vacuum environment?
Well, that is something I get asked very often. So I do believe that it's indeed a very good question. So many people think, okay, near vacuum, why are aerodynamics actually so important? Well, as the tube is, as said, in near vacuum environment, and some of the engineers out there might bear with me in knowing the lift formula, and there we see that the drag is actually proportional to the density of air. So if we say we go at 0.1% of atmospheric pressure, then our drag will also reduce to a 0.1 of its original drag value. But the major component which actually limits the possibilities of a normal train in a tube is the so-called Kantorovitz limit, or also isentropic contraction limit for all the aerodynamicists out there. And it is actually comparable to a supersonic wind tunnel, but now I'm going a little bit way too much into that. You can read up on that. Also, you can check it out at Hyperloop Connected, a platform we have within our team where you can read up all on those very technical aspects. And just within this Kantorovitz limit, this is why the aerodynamics within the Hyperloop field is also so complex. And I'm looking forward to many more research years to come. Thank you.
Thank you, Kat, for your answer. So, a question for Joost. What were the biggest challenges in designing a new long-term strategy, and how did you cope with them?
Well, that's a very good question. Yeah, I think the most difficult thing for us was basically to decide what our approach would be, because all three of us, we've never had to do like a job like this. So yeah, basically it was just the most difficult thing to decide where do we start, basically. And there we had a lot of help from the team of the guys who are sitting here next to me, because they really took us by the hand and showed us around the base immediately, and they gave presentations about what they were doing, how the pod, what the pod consisted of. And that's because of that we felt really comfortable from the beginning. And from there we just we just began by talking to the team, talking to the industry, talking to the university, and that way we started the process of defining the strategy, basically.
All right, clear. Thank you. A question for you, for Timo. What are linear motors? Can you explain it? Or is that a hard question?
Yeah, I'm really curious to that as well.
Maybe Joost can explain.
Nice that they ask a software engineer what linear motors are.
Maybe you
I
can
think the
explain.
short answer is I do, but I cannot explain how they work. Is that the...
I think I have the same, basically. I know the concept, but what it actually does gives them different.
Okay, so no answer. Kat, Sam, do you know? Do you know can you explain what a linear motor is?
I am not an expert, but for our propulsion we used wheels, which was very obvious from the documentary, of course. And we chose this because of the whole SpaceX Hyperloop pod competition. For us, this was the best way to gain as much traction and have the highest speed possible. But in an actual Hyperloop, this would not be the best option, probably, wheels. So you would have to propel the vehicle while levitating, and there is no rotary transmission that you can apply. So you have to make, it's kind of a rotary motor, but then stretched out, so rolled out, and you can still apply the electromagnetic forces. So these are kind of similar to the motors we use. However, they are just stretched out over a linear pattern, and yeah, they enable you to have just a linear propulsion and not a rotary and then transmission. That's, I hope, very basic and kind of in the right direction, but if you are very keen to find out, there is a lot of literature on it. Linear motors.
And of course, we can be looking forward to next year. What is yet to
course,
come.
Yeah. And we're very happy to help the new team with thinking about solutions.
Thank you very much.
I think we have to ask this question again next year, then there will be a lot of answers for you.
Next year, don't hire me, Joost, because I have no idea.
Okay, we'll do that. Okay, then a question you maybe can answer, Timo.
Yeah, all right.
Okay, how do you make sure the pod comes to a safe stop if anything goes wrong?
All right, so yeah, I was maybe funny story to start with. I'm now working on a project to automate imaging of the heart, and I was at a hospital visiting to sort of familiarize myself with heart echoes, and then the doctor asked me, do you want to make a heart echo? And like I was a bit scared of that because last year I've had at least 50 near heart attacks from like being responsible for the software that has to stop this thing because it's going 400 kilometers an hour, and if I make one mistake, then the whole team is fucked, basically. So how it works is that we have a lot of sensors in the wheels. We have also like the sensors in the wheels. They count rotation, and on top of that we have sensors that count like the battery voltages, or they measure the battery voltages. They measure pressure in the braking systems. We have sensors that detect strips on the track that tell us where on the track we are. So we have a lot of sensor information, and we know what nominal value should be. So if everything goes right, we know what the values would be somewhere throughout the run. So we put safety margins on those, saying if at this point of the run we get this sensor value, that's not right, and then we hit the brakes. So what happened during the last run was that one of the motors actually short-circuited, and that caused one of the motor controllers to lose connection, and then the system detected that and hit the brakes. So I was quite happy that I actually did that, because you know in front that this system is so complex that there's so much that can go wrong, and you also know that you can you try your best to think of every possible situation that go wrong and then have a good reaction to that. But you also know in your mind that that there might be something you've missed, or that you made a mistake in your code, and then it's really terrifying knowing that this thing is going 400 kilometers an hour and you're just happy that it stops. And yeah, the team itself seemed to have way more confidence that it would always brake at the point it needed than I did. So we had like this short test track in our base. It was like 20 meters, but within 20 meters, this thing is already going like 80 kilometers an hour inside. And people were putting cameras on the track to make videos, to like cool videos, and I was like, well, it might stop a meter too late, guys. Like, they were way more confident, but in the end, everything went right, so I'm really happy with that.
Thank you, Timo. Okay, question for Kat. Was it difficult to keep the team together after the COVID crisis, or maybe in this COVID crisis?
Okay, that's quite an interesting question, but of course very reasonable to the situation we're living in. I believe that this is a question that is, I think, answered individually by every single person within the team, because it's of course a very individual prospect you have on this situation. But I do believe in general we can say that we tried to have as much virtual interaction as possible within the team. So we set up different workshops, such as we had a baking workshop, I believe. We had a yoga workshop. We even had pub quizzes. So we did try to have here and there as much interaction as possible, but it did make it difficult. But I do believe that everyone in all different industries experienced the same difficulties.
Thank you, Kat. A question for Joost. Where do you see Delft Hyperloop in a year from now, or maybe in 5 years from now? Let's start with 5.
Okay, 5 is quite difficult since we just defined a strategy for 3 years. But
yeah.
of course, we can think about what happens
that's
afterwards.
That's why I ask it.
It's of course. So in 3 years, we basically thought of an idea where we want to be, and that is that we want to work more towards what we actually see as the future of Hyperloop, instead of having to rely on a third party and basically drag racing on the rails in LA. However, that's also really nice to go to LA with the team. So maybe we can set up a competition there in 5 years or anything like that. I'm not sure. But yeah, basically after the 3 years, I think that we want to keep innovating towards what we think that the Hyperloop will look like in the future. And if that image changes in the coming 3 years, then of course I think we should have to adapt our strategy to that. But I think in 5 years we will continue to engineer, to research, engineer and compete to get as close to the actual implementation of Hyperloop and try to contribute as much as possible, being a small student team with of course not the resources that the real big Hyperloop companies have, but still trying to contribute as much as possible as a team. So I hope that answers your question.
Yes, of course. Thank you. Sam.
Yes.
What was the most difficult thing to deal with personally over the course of the year? What was your biggest struggle?
Ooh, biggest struggle. That's hard. It's also very loaded all of a sudden. Yeah, I think I would have to go with one of the most obvious ones, which is COVID happening, and in the second place because it stopped us from working as hard as we wanted to. We were really like getting on steam and really going very fast, and then it happened, and we had to, of course, dial it back a lot. But the main thing that was the main setback because of COVID was not seeing the team, because it's 30 people you see every day, and it's all the little things that make it so much fun to be in a team like this. And yeah, that suddenly disappeared. So like Kat said, we did a lot of things to still keep in touch, and thankfully we could also kind of pick up the pieces back again and finish with this great result. But there was a period that was kind of sad to just be at home and really want to continue with the project and really have a final vision, but not being able to completely and fully devote yourself to it. I think that was the hardest part, and then also with the social side falling away. But I think in the end we managed very, very well, and the result and like the period after we could start back up a little bit, and like the period between that and the final run is the most insane few weeks I have ever had of working 16 hours a day, and the thing just combining and then happening. So with this biggest low, so to say, there was also the biggest high, which was finishing the actual vehicle with the whole team. So in the end it worked out. But good question, very nice loaded question on this light evening. But, no.
Thank you, Sam.
Good question.
Now the last question. Who wants to answer the last question? Okay, maybe it's a really hard question again. When is the Hyperloop a hyper reality? So when am I actually taking a Hyperloop to Paris? What do you think?
Well, then I will take the possibility to answer the question as far as I can. From the research we have seen, and also with the partners we have talked about this topic, is that we could see it happening in 15 to 20 years. So for instance, the company that was working very closely with us, Hard Hyperloop, they focus at first mainly on payload and not that much on the human factor, but slowly with time they will also involve the transporting people from A to B. But there's still so much yet to come. There's not only the technology, mostly of the technology we have accomplished it already, but there are major human factors such as the implementation, the legislation. They're all aspects that still need to be addressed. So I do believe and hope that in 15 to 20 years we might see it in reality.
Nice, good answer. So that was the last question. Thank you everyone for all the interesting questions, and you guys for answering them. If you still have questions, you can ask one of our teammates yeah, during the during the drinks, borrel. So yeah, that's it. Thank you very much. And yeah, the team, please stay here. We're gonna make a team photo, and the rest can go. Yeah, please wait a few minutes because you will be seated, and then we will see you in 5 minutes. Thank you.
Thank you all for coming, guys.